நிஷிகா, நீங்க சிபிஎஸ்சியா நீங்க? நிஷிகா, கேன் யூ ஹியர் மீ?
எஸ் சார்.
ஓகே. எந்த ஊர் நீங்க?
நாகர்கோவில்.
நாகர்கோவில். ஓகே, வெரி குட். நீட் ப்ரிப்பேர் பண்றீங்களா நீங்க?
இல்ல ஜேஇ.
ஜேஇ. ஓகே. ஓகே. தமிழரசி, தத்வதிகா, உபாசனா. ஓகே, வெரி குட். ஐ திங்க் யூஸ்வலாக வர்ற ஸ்டூடெண்ட்ஸ் எல்லாரும் வந்துட்டீங்கன்னு நினைக்கிறேன். டினோ, டெல்ஃபின் யாரும் புதுசாக இருக்கீங்க. ஃபர்ஸ்ட் கிளாஸ் வரீங்களா டினோ, டெல்ஃபின்? ஓகே, ஸோ வில் கெட் ஸ்டார்டட். நான் இப்போ பேசுறது மைக் இல்லாமல் பேசிகிட்டு இருக்கேன். ஸோ கரெக்டாக கேட்குதா? இல்லை ஏதாவது ப்ராப்ளம் இருக்கா?
Yes sir, it is audible.
It's audible. Okay, very good. I think this should be good. This is more comfortable for me. So did any of you try some problems from the file which I sent you? Were you able to work out the remaining problems? Any doubts to be answered? Or I can show you, I can open that file and then, we can see. If you want, we can solve, few problems in that, and then we can go to the next chapter, which is thermodynamics. So I given the subtopic names over here, okay, so that it's easy for you to understand which topic we are talking about. These things we have discussed. Inversion temperature, I think we didn't discuss this. Maybe I can quickly talk about this. Anybody tried this? So it's coming in your 12th standard current electricity also, right? So inversion temperature means there will be, we are talking about thermocouples. So thermocouples, what happens is, anybody who will not follow Tamil, if I speak in Tamil, everyone can follow Tamil. Tino, can you follow Tamil or not? Okay, I will better talk in English. If you have any difficulties, you let me know. Okay. So this is thermoelectric EMF. This is cold junction, temperature at cold junction. This is called the inversion temperature. This is called the normal temperature, neutral temperature. What this means is, as you keep on increasing the hot junction, right? So what is a thermocouple? You have a cold junction here. You have a hot junction here. So suppose if I connect some dissimilar metals like copper and iron, what they say is there will be some current flow here. So suppose if I put a ammeter over here, you will see some current, something like copper, aluminum, something like that. So what they say here is, as I keep on increasing the hot junction, this is cold junction, this is hot junction. So as I keep on increasing this temperature.
Sir, I think you are not presenting the screen, sir.
change the screen. Okay, can you see me now? See the screen now?
Yes, sir, it is visible.
Okay, very good. If I forget to switch on this present mode, you have to tell me, right? If you keep quiet, if you know, it means. So please, let me know if I forget. So all this time, you folks have not seen the screen at all. Okay, that's interesting. So So that means I was telling that you have a cold junction, you have a hot junction, right? And then you have some dissimilar metals, copper and aluminum. And if I connect it like this, there will be some current flow. And that is what we call it as thermo EMF, the voltage difference here. And this is cold junction temperature, 0 degrees Celsius, something like that, minus 5 degrees Celsius, something like that. And if I keep on increasing the hot junction temperature, what will happen is the thermo EMF will keep on increasing, and at some point it will start decreasing. And in fact, after this, after a point, it will start going in the negative temperature, negative voltage. The voltage will reverse. So this is why it's called inversion temperature. So make a proper note. I will send you some notes for this. So this is cold and this is the inversion temperature. This is a neutral temperature. So if you don't know this diagram or graph, you will not be able to do this problem. Why theta? Because generally we use capital T for Kelvin temperature. And sometimes or many times we use theta for Celsius temperature. Okay, so just to make sure that we don't make any confusion here, right? Capital T for Kelvin and theta for Celsius. So this, if I keep on changing the hot junction temperature, as I told you, it will go like this. So general formula we will use here is theta n is equal to theta c plus theta inversion divided by 2, something like, it will be in the center. And suppose if I change the so in some other trial, if we change the system, what will happen is the theta n will remain the same, even if the inversion temperature changes. If I change the cold junction temperature, this inversion temperature will change, but the theta n remains the same. Okay. So again, this will be theta c here, and this will be theta I here. So coming back to the problem, right, I can say using this formula, I think we should be able to solve this. Temperature of inversion of a thermocouple is 620 degrees Celsius. So this is 620. What is the temperature of the cold junction? So theta n is equal to theta c plus theta I divided by 2. So theta n is 620. Sorry, inversion is 620. Theta c is what is asked. Theta n is 300. So 600 minus 620, so I'll be getting minus 20 degrees Celsius. Any questions? So take down these concepts, very important. Okay, only if you know this, you'll be able to do all the thermocouple based problems. Can I go to the next one? Anybody copying? You see, this is also based on the same concept. If the cold junction of a thermocouple is kept at 0 degrees Celsius and hot junction is kept at T, I think something is not correct here, temperature of the inversion. So you can use the same logic. Theta n is equal to theta c plus theta inversion divided by 2. There is a lot of confusion here whether it is I or J. I think this is I. Inversion temperature is I, not J. So they have taken it as T, given it as Ti. Cold junction, they gave it as 0 degree. So that means I can substitute 0. Neutral temperature, they are giving it as Tn. So that means the answer will be Ti by 2. It's not this, it's not this. I think something wrong with the letters. Okay, maybe this must be Ti by 2. Any doubts? Just direct formula application. Okay, these things we already discussed it. So people who didn't attend the previous classes, go back and study all these things. Okay. Anybody tried this problem? Thermal capacity of 40 gram of aluminum. How to calculate? Remember, all these things are past NEET questions. Okay, if you are serious about NEET and JEE, you have to work out all the past paper questions. Nobody wants to answer it. Okay, I can give you a quick idea. So thermal capacity of 40 grams. So that means it's not specific heat capacity, right? It's a heat capacity. So remember in the first class I talked about this. Suppose if I paid 50 rupees per kg of apple, and if I bought 2 kg, then I would have paid 100 rupees. So this is per kg is yours, something like your specific heat. This is something like your amount which you pay. This is your total heat capacity. This is specific heat capacity. I'm just giving some simple analogy so that it's easy for you to understand. So that means they're asking for 40 grams, right? So that means in this place I have to put 40 grams. So specific heat capacity of aluminum is given as 0.2 calories. Per gram per Kelvin. That means the gram will cancel. I'll be getting calorie per Kelvin. So that will be my heat capacity. So point and 0 will cancel. So 4 into 2, 8. 8 calories per Kelvin. But then they are given it in joule. So what should I do? Anybody? Anybody? What should I do to convert it to joules?
Into 4.2.
Into 4.2. Very good. So how much will you get? 32 something, 32, something close to 32. So yeah, this looks correct to me. Okay. You don't have to waste your time, calculating the accurate numbers because all the other numbers are very far away. So I know that something close to 32. Any questions? Can I go to the next one? These things you already discussed. Okay, this is an important type of problem. An electric kettle takes 4 amp current at 220 volt. How much time will it take to boil 1 kg of water from temperature 20 degrees Celsius? Boil means 100 degrees Celsius, right? So 20 degrees Celsius to 100 degrees Celsius. So that means whenever you are talking about something like this, I should remember the heating curve topic. So that means 20 degrees Celsius is here. Boiling means it's here, 100 degrees Celsius. And this is 0 degrees Celsius. So that means the temperature. So how much time will it take? So they're asking to find the time. So electric kettle is giving the energy. So always I will start with the basic underlying principle. Q lost is equal to Q gained. Instead of saying, so water is going to gain it. But instead of saying Q lost, the electric kettle is giving the heat, right? So Q given. You can call it as Q given by kettle, electric kettle. So you know that Q is energy. I know that electric power is voltage into current, right? So somewhere current will give me power, and if I multiply by time, I will get the heat energy. So that means Q is equal to VIT. Q gained is, we are talking about from here to here. So since it is a slanting line, you should use, will you use MC delta T or ML? That's all. After this, it's just a matter of substituting the numbers. So current is 4 amps. Time will be in seconds. Don't forget this will be in seconds, right? Because it's in the SI units, which means I need to convert it to minutes then. So mass will be 1 kg of water. Specific capacity will be 4,800 or 4,200 joule per kg Kelvin. Kelvin and Celsius are interchangeable when we are talking about delta T. Delta T will be 100 minus 20, which will be 80. Do the math and then divide by 60 to convert it to minutes. Okay, so I leave it to you. Do it and get the answer. Anybody getting the answer quickly? 0, 0 will cancel. So 8 divide by 60, 5200. Any answers? I think it should be 6.3 something. Anybody getting that? Okay, I will leave it to you. Anybody got the answer? Only if you folks are responding, I will feel comfortable. Okay. Last class, some students were interacting well. This class, nobody is opening their mouth. I don't know what happened. Okay. You don't see anybody is telling me, sir, I finished these problems. So that means I think I still have to do these problems. Right now, it should be holidays for you folks, right? You make use of the time. Probably you can solve a lot of past paper questions. Okay, I will give you the concepts quickly. The mathematical part, I will leave it to you. Okay, if you want, you do it. Otherwise, you can directly do in your exams. Slab of stone area is given, thickness is given, it's posed on the lower surface of steam. So that means a slab lower surface to steam at 100 degrees Celsius. So that means it's like now steam at 100 degrees Celsius. Block of ice 0 degrees Celsius. So that means on the top, let's say have some ice. In 1 hour, 4.8 kg of ice melted away. So that means because of the heat, the water is the ice is melting to water. So in 1 hour, they said 4.8 kg of ice is melted. The thermal conductivity of the slab is, so they are asking to find the thermal conductivity K. So I would say the heat conducted over here, right? The heat is flowing over here. So the heat flow rate, thermal conductivity Q given. Generally, we will write Q lost is equal to Q gained. But in this case, I would say Q given, right? That is confusing. You can write as Q lost, but it's not losing heat, it is giving heat, right? The slab is giving the heat. But then remember the thermal conductivity formula, it should give you H is equal to dQ by dt, meaning heat flow rate Ka by L into delta T. We already saw problems based on this. Okay, you should know these concepts. I already explained you. So that means here what I can do is I can put this Ka by L into delta T multiplied by time. Why multiplied by time? Because if I want energy, I have to multiply by time. Okay, so this is energy. So this is power or heat flow rate. That means multiply by time. Q gained is ice is converted to water, which means we are talking about ice over here and then converted to water here. So that means it should be Q is equal to MLF. So this will be M into LF, latent heat of fusion, given over here. Thermal conductivity K is asked. So all you have to do is substitute the numbers and we'll get the answer. But I think it's given in 1 hour. So that means I have to multiply by, I have to take it as seconds. The thermal conductivity K, area is 0.36 meter square divided by length is this thickness 0.1 meter. Multiplied by delta T. Delta T is 100 to 0. So that means 100. Sorry, multiplied by time. Time is 3600 seconds. Is equal to mass is 4.8 kg. LF is 3.36 into 10 power 5. That's all. So do the math and get the K value. Okay, I will leave it to you. messages. I heard a thing here. Any questions so far? This is an easy one. Liquid oxygen at 50 Kelvin is heated to 300 Kelvin at constant pressure of 1 atmosphere. The rate of heating is constant. Which one of the following graphs represents the variation of temperature with time? So you know that the heating curve should look something like slanting and horizontal lines. So I would say A should be the correct answer. Okay, so this is your heating curve. All the others, they don't have any. This has a slanting line, but it doesn't have the straight line, horizontal line. Remember, liquid oxygen is getting converted to gaseous form, which means obviously there will be some phase change. So this is wrong, this is wrong, this is wrong. So this sounds correct to me. Remember, 300 Kelvin is room temperature. In room temperature, you know that it is gas. In room temperature, oxygen is in gaseous form. So that means from 50 Kelvin, it is coming here, and then it is coming over here. So liquid to gas. Okay, any questions? I think I just have to keep on taking the class myself. Maybe I can send you a recorded video. Nobody is participating, saying anything. Are you following everything? At least say whether you are following it.
Yes, sir.
Yes, sir. Okay, very good. நீங்கள் நல்லா இன்ட்ராக்ட் பண்ணீங்க அப்படின்னா ரொம்ப யூஸ்ஃபுல்லாக இருக்கும். இன்ட்ராக்டே பண்ண மாட்டேங்கிறீங்க, சைலண்ட்டாக இருக்கிறீங்க. அட்லீஸ்ட் தத்வத்திக்காக நீங்கள் கொஞ்சம் பேசுகிறீங்கன்னு நினைக்கிறேன். ஸோ இன்ட்ராக்ட் பண்ணுங்கள். அதர்ஸ் தன்யாலக்ஷ்மி ஏதாச்சு பேச மாட்டேங்கிறீங்க. தமிழரசி, டீனோ. ஸோ யூ ஹாவ் டு இன்ட்ராக்ட். Steam at 100 degrees Celsius is passed into 20 gram of water at 10 degrees Celsius. When water acquires a temperature of 80 degrees Celsius, the mass of water present will be. Okay, this is slightly longer one, but I will give you the concept. You can try it yourself. We have done many problems in this heating curve. The reason I'm doing a lot of problems in heating curve is definitely it's important one, and then it's slightly confusing. It's not like a direct formula substitution. Stephen's law, Wein's displacement law, all these things are direct formula substitution. Newton's law of cooling. But this one is not direct formula substitution. Only if you think a little bit, you will be able to solve it. Otherwise, you will not be able to solve. Steam at 100 degrees Celsius, which means it's not here, it is here. This is 100 degrees Celsius water passed into 20 grams of water at 10 degrees Celsius. So 10 degrees Celsius means somewhere here. The water acquires a temperature of 80 degrees Celsius. Grams water. Okay. So water reaches 80 degrees Celsius. The mass of water present will be 20 கிராம் வாட்டர் இருக்குது. அப்போது இங்கே டெம்பரேச்சர் ரைஸ் பண்ணுறதுக்கு ஸ்டீம் அனுப்பணும் அப்படின்னாக்கா எகெயின் இங்கே 20 கிராம்ஸ் தான் இருக்கும். கரெக்டாக? இல்லை do you expect to see some other value? Any answers? 20 கிராம் சேமாக இருக்குமா, இல்லை அதோட ஜாஸ்தியாக இருக்குமா, இல்லை கம்மியாக இருக்குமா? Will it be more than 20 grams, less than 20 grams, or same as 20 grams? Nobody wants to answer. If I send steam through water, what will happen? Steam will give out heat, which means it will become water, which means the amount of water would have actually increased. So in addition to 20 grams, it would be slightly more than that. Okay, so that means this is coming from here to here. Steam is coming from here to here, but they didn't tell you how much steam is given, right? So it's coming from here to here. Remember, whenever we are talking about water, it's easier to deal with calories instead of joules. And remember, in this slanting line, it is 1 calorie per joule per 1 calorie per gram per Kelvin. Okay. Yeah, 1 calorie per gram per Celsius or Kelvin. Latent heat of steam is given as 540 calories per gram. So again, the same concept, Q lost is equal to Q gained. There is only one concept you have to understand properly. Who is losing the heat? Steam. Who is gaining the heat? Water. Okay. I do not know the amount of steam used. So maybe whenever I don't know something, I will take it as X grams. Why grams? Because they are given it in grams. So that means X grams. So 540 calories per gram. But remember, if I do this alone, very important, listen carefully. If I do this M into LF, LV, sorry, latent heat of vaporization. If I do only this, I'll be considering only this straight line, horizontal line. What about this line? So in addition to this one, this is losing heat to come down to 80 degrees Celsius, which means don't forget we need to add this also, the slanting line, which is MC delta T. So again, I do not know the X grams. Specific capacity of water is 1 calorie per gram. So 1 calorie per gram per Kelvin or Celsius. Multiplied by delta T. Delta T, it is coming from 100 degree to 80 degree, which means it should be 20 degrees Celsius. That should be equal to the heat gained by the water, which is MC delta T. This one, which is M is mass of the water, 20 grams. Specific capacity is 1 calorie per gram per Kelvin. Remember, calorie is the amount of heat required to raise the water, 1 gram of water by 1 degree Celsius. That's why you are getting 1 calorie. Delta T is from 10 degree you are going to 80. So that means 80 minus 10. So it will be 70. That's all. Do the math and you should be able to find the X. But remember, they're asking the mass of water present will be. So that means in addition to this, you have to add the 20 grams of water. Because initially you had 20 grams of water and then the steam has been converted to water, which means 20 gram plus X will give me the answer. Any questions? Any answers quickly? I'll give you 2 minutes. Quickly solve this and tell me. Take the X commonly out. So 20 plus 540, I'll get 560. 560, zeros cancel. 6, 8 times. So 20 divided by 8. Anybody getting 2.5 grams? X.
Yes, sir.
Okay, that means what will be the water percent? Amount of water percent. So 20 plus 2.5.
22.5.
5. Is that correct? Are you getting it?
Yes, sir.
Okay, very good. Okay, again and again I'm telling you, heating curve problems are easy, but you have to do a little bit of thinking. If you forget to put this part, you will get a different answer. You should understand that you are coming from here and then you are coming from here. So this is not a direct formula substitution. You have to think a little bit. Okay. Anybody copying? Can I go to the next one? Okay, this we solved it in the last class. Of course, I'm documenting all these things. You can go back and study. Okay. A piece of ice falls from a height of h. So that it melts completely. Only 1/4 of the heat produced is absorbed by the ice. So that means 1/4 of the heat is used for melting. Okay. So that means the potential energy here should be converted to kinetic energy here. The kinetic energy should be converted to heat energy. But however, they are saying, suppose if I had 100 joules of heat, not all the 100 joules are used for melting ice, only 1/4 is used. That means potential energy converted to kinetic energy is converted to heat, and out of that, 1/4 is used for melting the ice. That means the value of H is what is asked. So again, always I know only one thing, which is Q lost is equal to Q gained. Q lost, or you can say Q given. Okay, electric kettle is giving here, this system is giving, right, potential energy or kinetic energy is giving the heat. So that means Q gained is your ice. So that means ice is getting converted to latent heat of ice. So it's getting converted to absorbed by the ice. Okay. So that means it will be M into LF. Okay. And this energy will be potential energy, which is equal to mgh. So the energy here will be mgh. But remember, they said potential energy is converted to kinetic energy. Kinetic energy is getting converted to heat energy. That heat energy is given here, but only 1/4 is given here, which means don't forget, you should put 1/4 here. Let's all do the math, and LF is given. Any quick answers? M can be cancelled out. G, they said you can take it as 10 Newton per kg, right? What is this 10 Newton per kg? Instead of 9.8, you can approximately take it as 10. Either you can say meter per second square or Newton per kg, because it is a gravitational field strength. Okay. Because Newton is kg meter per second square divided by kg. So kg will cancel. I'll be getting meter per second square. So don't get confused. The gravitation chapter, somewhere in your gravitation chapter, go back and check the handbook notes. Okay, so I must have given this. That's all. Simply substitute the numbers, you should get the number and get the answer. H is what is asked. LF is,
Yes, sir.
how much are you getting?
136 kilometer.
136 kilometer. Okay, very good. That sounds correct. Okay. Anybody else getting the same answer? (34 into 4), I think. Yeah, 136 sounds correct. Yeah. As I always say, try to make a simple drawing. Once you start making a drawing, your brain will start working. It's like a magic. Okay. For me, I don't know about you. For me, only if I make a drawing, my brain will start working. Once my brain starts working, I will think, okay, what are the concepts I know related to this? And then once I know the concepts, I can substitute the formula. I mean, I can put the formula. After putting the formula or the underlying principle, after that, it's just a matter of substituting the numbers. Okay. Okay. These things we already discussed. The easy one, I will leave it to you. Thermal conductivity, I think I will leave it to you. Try it yourself. If you're not getting, bring the doubts. Maybe we can try this one. A cylindrical metallic rod in thermal contact with two reservoirs of heat as its two ends conducts an amount of heat Q in time T. Amount of heat flowing is given as Q in a time T. Metallic rod is melted and the material is formed into a rod of half of the radius in the original rod. What is the amount of heat conducted by the new rod? So that means half the radius. So if this was R, this must be smaller than that, half the radius. Means it is R by 2. They said melted and then recast like this, which means obviously you should imagine that if the radius is reduced, the length will become larger, right? So in other words, the volume is kept constant, because when you melt a metal, the volume of the metal will remain the same. So now they are asking you what is the amount of heat conducted by the new rod. So that means they're asking you the Q2. From the basic knowledge, I know that if the area decreases, the heat flow will decrease. If the length increases, the heat flow will decrease. So that means 2 times Q is wrong. So I think the answer should be between A, B, or D. So it means the first case, Q by T, which is your Q by T, energy by time, heat flow rate, K A by L into delta T. Thermal conductivity area is pi r squared. Delta T is going to be the same. Remember, the length will change and the radius is changing, right? Which means you have to use a volume relationship. So volume 1 should be equal to volume 2. Volume 1 will be pi r squared into h. You can say height or length. This length L. This should be L2. This will be pi r squared. R squared will be r by 2 the whole square. And the length is what? I do not know. L2. So I'll be getting 1 by 2 square, which is 4. So L2 is equal to 4 times L. So that means this will become 4 times this length, original length. After that, simply substitute, write the equation for the second, the same. Why am I writing this? Because heat flow rate is equal to energy by time. Thermal conductivity, same material, right? Which means even if you melt it, the thermal conductivity remains same, K. Area now has become pi r by 2 the whole square divided by length. Length is L2. L2 is 4L into delta T. Delta T, I think they said delta T is the same. The two reservoirs in time, the same two reservoirs. After that, it's just a matter of equation 1 by equation 2. Anybody got the answer? So Q2 cross multiply, so Q2 will go here, Q1 will be here, 4 will go to the top over here. So here I have 2 squared, which will be 4. So this will become 1 by 16. So 1 by 16 will be coming over here, so it will be Q1 into 1 by 16. That means Q2 is Q divided by 1 by 16. Whenever you get these kind of problems, I call it as equation 1 by equation 2. Very, very easy if you just follow the formulas. Anybody not following any steps, please raise your doubts. Very easy and very often asked. This is 2 squares, so 4. This 4 and this 4 will come in the denominator, so 1 by 16. So 1 by 16, if I do the cross multiplication, I'll get something like this. Two metal rods, 1 and 2 of same lengths, have same temperature difference between their ends. Same lengths, metal rods 1 and 2. The thermal conductivities are K1 and K2. And cross-section areas are A1 and A2 respectively. The rate of heat conduction in rod 1 is 4 times. So same temperature difference, same length. So that means I can imagine something like this. So K1, K2, area 1, area 2. Same length, L, L. Rate of heat conduction in rod 1. So rate of heat conduction in rod 1 is, remember, listen carefully, is means equal to 4 times. 4 times means multiply by 4. That in rod 2, which means H2. Okay. I call this as translating from English to maths. So if you don't know to translate this information into math, right, then you cannot do these problems. That's all. I think after that it's very easy. So H1 is equal to 4 times H2. Heat flow rate is nothing but thermal conductivity K1, area 1 divided by length 1, but length is same, so I can leave it as L. Delta T is same. 4 times area 2 divided by length into delta T is same. That's all. So I'll be getting K1A1 is equal to 4 times, did I miss a K here? K2 is missing, K2, A2. See if you have that option. B, yeah. Very often you folks will make a mistake here. So simply follow the sentence, okay? Rate of heat conduction, which means H1. Yes, this means equal to, is equal to. 4 times means 4. That in rod 2, that means what? Heat conduction in rod 2. So H2, that's all. Okay. In maths, you must have heard Ram is twice the age of Shyam. So Ram is means is equal to, Ram is twice the age of Shyam. Okay, you don't have to confuse at all. If you follow the sentence, you will get it. Okay, so translate English sentence into mathematical equation. Okay. Thermal conductivity, I think we have done enough of thermal conductivity. I will leave it to you. It's supposed to be easy one only. You can try it. Newton's law of cooling is what we did in the last class. Means displacement law, I think one class before, I think we did this in an earlier class. Okay. So the underlying principle is as the temperature increases, the wavelength where you get the maximum intensity will keep on decreasing. In other words, the energy increases. If the energy increases, frequency increases. So from your 12th standard knowledge, you should know that E is equal to h nu photon, right? Dual nature concept. If the frequency increases, you should know wavelength decreases. So that means you can see the wavelength keeps decreasing. Okay, this is what we discussed in the previous classes. Let us try one or two problems in Wein's displacement law. See if you are able to, do it. Just for your benefit, I have, put according to the subtopics. Okay, in this chapter, you have 5 subtopics. Heating curve is the important one, thermometers, and then Wein's displacement law, Newton's law of cooling, Stephen's law, and thermal expansion. Okay, and thermal conductivity and then thermal expansion. So you have some 5 or 6 different subtopics. Any questions? Try this quickly. I'll give you 1 or 2 minutes. Let me get some water. You folks try it. Did anyone get the answer? Danya, Maitri, Tatvatika, Untamularasi, யாராவது ஆன்சர் சொல்லுங்க. Anybody? Black body at 1227 degrees Celsius emits radiations with maximum intensity at wavelength of 5000. So that means lambda m into T is equal to your constant. Lambda m is 5000 angstrom. Temperature is 1227. Don't forget this is in Celsius, but these T's are in Kelvin. Whenever you see this 27, you should remember you have to add 273. To make it easy for you, they will give you something with 27 here. B is the Wein's constant. If the temperature of the body is increased to 1000 degrees Celsius, if you make a mistake of not adding 273, everything will go wrong. Remember, only when the Kelvin temperatures are taken with the difference, the Celsius temperature delta T in Kelvin and degrees Celsius are same. But here we are not doing delta T, okay? So keep in mind, only in heating curve this is applicable, not here. Okay, we are not finding difference, so you have to convert it to Kelvin. I'm sure they would have given an option with just Celsius temperature, and many people will be choosing that one. Maximum intensity here, they're asking you to find the delta M2, for example. Equation 1 divided by equation 2. Cancel it out and get the answer. Anybody getting the answer? here. So 273 means 1500. Divided by 1273. That will be my lambda m2. Any answers, anybody? Any answers, anybody? Nishika? Tatvatika calculate பண்ணலையா? 1 point something வரும்னு நினைக்கிறேன். 1 point multiplied by 5. I think it should be close to 6,000 பக்கத்துல வரணும். You get something close to 6,000?
Sir, I'm getting 5890 something, sir.
589. Okay. That is close to 6,000, right? இன்னும் கொஞ்சம் அக்யூரேட்டா போட்டிங்கனாக்கா I think you will get question number 25. Oh, we made a mistake here. Look at this. The temperature of the body is increased by 1000 degrees Celsius. Already நான் சொல்லியிருக்கேன். The common mistake. ஒழுங்கா படிச்சு பார்க்கல அப்படின்னா will make a mistake. Okay, so increased by 1000 நாக்கா already இருக்கிறத விட 1000. So that means 1500 plus 1000. So it will be 2500, which means the calculation will become much easier. Now what is the answer? 3 times 5 times, so 5 cancels, so I'll be getting 3000 as the answer. Okay va Tatvatika?
Okay, sir.
Okay, so I think we made a mistake, so exam la indha mistake பண்ணாதீங்க. Increased by அப்படின்னாக்கா actual value oda you have to add it. 1500 plus 1000, so it will become 2500. This is a very interesting question. A piece of iron is heated in a flame. It first becomes dull red, then becomes reddish yellow, and finally turns to white hot. The correct explanation for the above observation is possible by using, which one do you think? இங்கே ஆன்சர் கொடுத்துட்டேன். ஓகேவா? ஸோ விப்ஜிஆர் ஸ்பெக்ட்ரம் பார்த்தீங்கன்னாக்கா இந்த பக்கம் லாம்டா வந்து லோ இல்லையா, லோவர் வேவ் லென்த். சாரி, திஸ் இஸ் ஹையர் வேவ் லென்த். லாம்டா ஹை, ஃப்ரீக்வன்சி தான் லோ. இங்கே இந்த பக்கம் வந்து லாம்டா லோ, whereas the frequency is high. அப்போ நான் ஒரு அயன் பீஸ் எடுத்து ஹீட் பண்ண என்ன ஆகும் அப்படின்னாக்கா, இனிஷியலி இட் வில் பி ரெட்டாக இருக்குன்னு சொல்கிறாங்க, அப்புறம் எல்லோ ஆகும்னு சொல்கிறாங்க, அப்புறம் இந்த காம்பினேஷன் வந்து கொஞ்சம் வந்து ஒயிட் கலராக வரும். ஸோ ஆஸ் யூ கோ டுவர்ட்ஸ் ப்ளூ, ரைட், ஸோ இட் வில் பிகம் ஒயிட். இந்த எக்ஸ்பிளனேஷன் 100% கரெக்டாக இருக்கணும்னு தெரியல, பட் சம்திங் க்ளோஸ் டு இந்த காம்பினேஷன் வந்து இந்த ஒயிட் கலருக்கு வரும். ஸோ It's moving like this. So lambda வந்து குறைஞ்சிக்கிட்டே வந்தால் டெம்பரேச்சர் இன்க்ரீஸ் ஆகுதா கம்மியாகுதா?
Temperature increases.
Temperature increases. Which law talks about lambda and temperature?
Wayne's displacement law.
Wayne's displacement law, right? So lambda m into T is a constant. So as lambda decreases, as temperature increases, lambda decreases. So that means it should be Wayne's displacement law. On observing light from 3 different stars, PQR, it was found that the intensity of violet color is maximum in the spectrum of P. So PQR stars. So inga vandu violet color is maximum in the spectrum. So maximum naka lambda m is in violet. The intensity of green color is maximum in the spectrum of R. So inga vandu green color. Adha vandu lambda maximum irukku inga. The intensity of red color is maximum in the spectrum of Q. So inga vandu red. Just to confuse you, they are given the wrong order. P அப்புறம் R சொல்லிட்டு அப்புறம் Q சொல்லியிருக்காங்க. So make sure you follow that. If you make a simple silly error, everything will go wrong because we are talking about the relative values. So anybody, Tatvatika, Danya, சொல்லுங்க பார்ப்போம். எதுக்கு வந்து டெம்பரேச்சர் அதிகமாக இருக்கும்? இப்போதான் பார்த்தோம். ரெண்டு வந்து lambda high, அப்போ temperature will be low. Violet will be temperature high, and this will be temperature medium, somewhere in between. So that means P should be high, TQ is lowest, and TR should be coming somewhere here. TP, TR, TQ. So A should be the correct answer. Okay. Very often you know the concept, but because of the order you may make some mistakes. So don't make that mistakes. Okay. Black body is at a temperature of this thing, and the energy of radiation emitted by the body at wavelength is this much, is U1 at wavelength 500. So 250 nanometers is giving out energy of U1 at wavelength 500 nanometers is giving out energy of U2. That at 1000 nanometers, U3. Wayne's constant, which of the following is correct? Black body is at a temperature of 57, energy of radiation emitted by the wavelength. So now it's slightly different. So what they're saying is the temperature is kept constant. அப்போ ஒரே ஒரு curve தான். So we are not talking about two different curves. The drawing கொஞ்சம் conceptual think பண்ணாதான் இது பண்ண முடியும். So that's your 5760 Kelvin. This is your energy distribution or intensity. Intensity is nothing but energy by area by time. இதுதான் வந்து நம்ம வந்து lambda mன்னு சொல்லிட்டு இருக்கோம். maximum. It's not maximum wavelength, it is the wavelength where the maximum intensity is occurring. Yeah, the lambda mக்கு meaning. $250 nanometers இங்கே எங்கேயோ இருக்குன்னு வச்சுப்போம். இது வந்து 500 nanometers, இங்கே வந்து 1000 nanometers. So that means they are given the B value, which means I can calculate the values here. So let me use the formula. Lambda m into temperature is equal to B. Lambda m 250 nanometers means which of the following is correct? Lambda m 5760 Kelvin. I can substitute here. B is 2.88 into 10 power 6 nanometer Kelvin. So lambda m, I can get it here. Do the calculations and tell me how much are you getting for lambda m. I think this will go 2 times. So 2880 we cancel. So 10 for 3. So I think it will be 500. 0.5. So double check that. I think you should be getting 500 nanometers. So that means based on this, I know that the maximum intensity, right? This is your maximum intensity or maximum energy. You can, in this problem, I can call it as maximum energy. என்ன அர்த்தம்? இது மேக்ஸிமம். அப்போ இது வந்து U2, இது வந்து U1, இது வந்து U3. So that means U2 will be higher than U1. So this is the correct answer. Sorry, U2 is higher than U1. Is that okay, Tatratika, others?
Yes, sir.
Okay. மற்றவங்களா ஃபாலோ பண்ணுறீங்களா? சவுண்டே காணும். Okay, this one I will leave it to you. So இதே கான்செப்ட்ஸ் தான். ஸோ ட்ரை பண்ணுங்க. And I'm sure it will be easy only. தெரியலன்னா I will do it. Stephen's law, let us do 1 or 2 problems and then we can wind up for today's class. So I told you Stephen's law is also very easy, right? We talked about this. Intensity is proportional to temperature power 4 Stephen kandupicharu. And then he brought in a Stephen constant, sigma T power 4. This is your Stephen's constant. But what is intensity? It is power by area solala, intensity. But what is power? Energy by time. is what is equal to sigma T power 4. It's a very easy concept, but in the intensity, power, energy, in the three things will confuse you a lot. So always remember, it is not power, it is rate of power. So power per unit area. Okay, just a sec. Let me answer. I will be back in 1 minute. Somebody is calling. So I was telling Stephensல ரொம்ப ஈஸி, பட் ஆனால் இந்த பவர், எனர்ஜி, இன்டென்சிட்டி இதெல்லாம் போட்டு ரொம்ப கன்ஃபியூஸ் பண்ணுவாங்க. ஓகேவா? ஸோ இஃப் யூ நோ ஆல் தீஸ் திங்ஸ், இஃப் யூ ஸ்டடி ஆல் ஆஃப் தம் டுகெதர், கன்ஃபியூஷன் வராது. ஓகே, ஒன்லி இஃப் யூ ஸ்டடி தம் டுகெதர். ஒரு புக்கில் பார்த்தீங்கன்னா ஐன்னு கொடுத்துருப்பாங்க, ஒரு புக்கில் பார்த்தீங்கன்னா ஈன்னு கொடுத்துருப்பாங்க. ஸோ ரொம்ப கன்ஃபியூஸ் பண்ணுவாங்க. ஸோ வாட் எவர் லெட்டர் யூ யூஸ், this is intensity. Intensity becomes power by area. Power becomes energy by time. இந்த கான்செப்ட்ஸ் புரிஞ்சாதான் இந்த ப்ராப்ளம்ஸ் பண்ண முடியும், இல்லாட்டி பண்ண முடியாது. If the temperature of the sun is doubled, okay, what is the time? It's already 9:05. Let's finish this and then we'll stop. Okay. So if the temperature of the sun is doubled, the rate of energy received on earth will be increased by a factor of sun irukku. So this is emitting at certain temperature, right? In the surface temperature T. Inga earth irukku. Okay. So listen carefully. இங்க எமிட் பண்ற எனர்ஜி வந்து it is coming through this spheres. இங்க ஒரு ஸ்பியர் இருக்கும், இங்க ஒரு ஸ்பியர் இருக்கும், இங்க ஒரு ஸ்பியர் இருக்கும், இங்க ஒரு ஸ்பியர் இருக்கும். அப்போ சன்னோட எனர்ஜி எல்லாமே எர்த்துக்கு வருதானாக்கா கிடையாது. ஸோ இட்ஸ் கோயிங் இன் ஆல் த டைரக்ஷன். வெரி லிட்டில் போர்ஷன் ஆஃப் த எனர்ஜி இஸ் கமிங் டு த எர்த். அப்போ இங்க இருக்கிற ஏரியா, இங்க இருக்கிற எனர்ஜி should be equal to the energy in this imaginary sphere. Okay, I think I talked about this in some other problem. அப்போ power in should be equal to power out. அப்போ பவர் வேணா என்ன பண்ணும்? மல்டிப்ளை பை ஏரியா. அப்போ sigma into T power 4 into area is equal to, இங்க என்ன பண்ணோம், how much energy is falling here, அதான் solar constant சொல்லுவோம். Yes sir, into area 4 pi r squared. இங்க வந்து 4 pi capital R squared. இது என்ன சார் அப்படின்னாக்கா, இது கேபிட்டல் ஆர், ரேடியஸ் ஆஃப் த சன். இந்த ஏரியால இருந்து ரைட் வருது and it is coming to this bigger area. So how much energy per unit time is falling is what is your solar. Let me double check that. Handbook போனீங்கன்னா I think it should be there. Formula should be there for solar constant. think I given it in the radiation definitions, right? Go back and check in the handbook. So coming back to the question, this is the energy received in the earth. Or in other words, it's the energy received, energy per unit time, because we're talking about power. Per unit area, sorry. So you have to multiply by area also. So 1 meter square in 1 second எவ்வளவு energy? That is what we call as solar constant, yes. அதனால தான் இந்த பக்கமும் ஏரியாவால் மல்டிப்ளை பண்ணுறோம், பிகாஸ் திஸ் இஸ் எனர்ஜி பை டைம் இன்டு ஏரியா. ஸோ இஃப் ஐ மல்டிப்ளை பை ஏரியா ஐ கெட் எனர்ஜி பை டைம். புரிஞ்சதா தத்வதிகா? ஏதாவது டவுட்ஸ் இருக்கா?
No, sir.
ஓகே, அப்போ இதுக்கப்புறம் இட்ஸ் ஜஸ்ட் a matter of substituting the numbers. So the temperature of sun is doubled. அப்போ the rate of energy received on the earth will be increased by a factor of, so இது S இருக்குனாக்கா, so for example sigma temperature is double, so 2T power 4. This is what they're asking, S2 4 pi r square. Equation 1 divided by equation 2. Do the math. I think all these things will cancel except for the S2 will come here. So this 2 power 4 will come here. So S2 will become 2 power 4 times S1. Which means it will be 16 times, I think. Is that correct? So solar constant na enna, intensity na enna, Stephen law, இது எல்லாம் தெரிஞ்சாதான் இந்த problem solve பண்ண முடியும். But once you know this, it's easy. Okay, so I think I'm going to stop here. I'm going to leave all the other things as homework. So I think we finished maybe 3 or 4 problems what are remaining, so you can try it yourself. 4 or 5 problems. Okay, Stephen's law, it's easy only. Okay, Nishika இருக்கீங்களா? தத்வதிகா இருக்கீங்களா? My 3 left. Tino ஆன்சர் பண்ணல. நிஷிகா ஃபாலோ பண்ணிட்டு இருக்கீங்களா?
Yes, sir.
ஓகே, யூஸ்ஃபுல்லாக இருக்குதா? புரிஞ்சதா?
புரிஞ்சது.
ஓகே, தத்வதிகா யூஸ்ஃபுல்?
Yes, sir, it is useful.
Okay, very good. Tino, I don't hear you talking at all. Tino, Delphin. Okay, thank you all. We'll stop here. Next class we'll get started with thermodynamics. Okay, thank you. Bye.
Thank you, sir.